You know that feeling when you download an app update on your phone
Oh,
and
yeah.
suddenly all the buttons are in different places?
Uh-huh.
Or worse, you try to upload a photo and the whole thing just
Yeah.
crashes.
Right back to the home screen.
Yeah,
It's annoying.
it is. It's super annoying. But that whole dynamic, that constant cycle of updates and fixes, is just the price of admission for modern tech.
Mm-hmm.
We all know that famous Silicon Valley mantra, move fast and break things. It's why we get cool new features, every other week. It's iterative. It's messy.
And it's fast. It works great for a social media app or like a food delivery service.
Sure.
But there is a very specific context where move fast and break things isn't just annoying. It's actually terrifying.
I can imagine.
Uh-huh.
So I want you to picture this. You're sitting in seat 14A on a transatlantic flight.
Okay.
You're 30,000 feet over the freezing Atlantic Ocean. It's nighttime. And that little coffee on your tray table starts rippling because turbulence is kicking in.
Right. That moment.
In that moment, do you want the software controlling the autopilot and the flaps to have been built with a let's break things and see what happens kind of attitude?
Absolutely not. In that environment, the mantra completely flips. It becomes...
Failure is not an option.
Exactly. And for about 40 years now, the aerospace industry has relied on a very specific, very rigid document to make sure failure doesn't happen. It's a document known in the industry simply as DO 178C.
Software considerations in airborne systems and equipment certification.
Ah.
Doesn't exactly roll off the tongue.
No, it's a mouthful.
Yeah.
But it is effectively the Bible for aerospace software.
And because safety is the absolute priority, there's this massive assumption in the industry that you have to build software the old-fashioned way to comply with it.
You mean slow, methodical.
The waterfall method, step by step.
Right. The idea that you can't be agile, you can't be flexible if you want to be safe.
It's seen as this binary choice. You're either fast and reckless or you're slow and safe. But today, we are unpacking a really fascinating piece of research that challenges that entire worldview.
We are. We're looking at a paper titled Beyond Tradition, Evaluating Agile Feasibility in DO 178C. And the mission here is, it's really provocative. The authors are arguing that safety regulations don't actually kill innovation.
Oh, that's a big claim.
It is. They're saying you can use modern, fast-paced agile methods, the same stuff Spotify or Google might use, and still satisfy the strictest safety standards in the world.
So wait, we can have our cake and eat it too. The safety of a commercial airliner combined with the development speed of a tech startup.
That is the premise. But to understand how that is even possible, we first have to understand the rule book. We need to really dig into what DO 170C actually is because it's widely misunderstood.
Okay, so let's start with the stakes. We threw around the term safety critical, but the source material gives us a pretty stark definition of what that actually means here.
Yeah, it's not just about a server crashing or losing some data. It's much more visceral. A safety critical system is defined as one where failure results in loss of life, injury, environmental damage, or, significant property loss.
So we're talking about aircraft flight control.
Rail signaling systems, medical devices like pacemakers, and increasingly, things like autonomous driving technology.
High stakes. If the code is wrong, people get hurt. It's that simple.
Exactly. And that is why DO 178 exists. It started way back in 1980 as just DO 178.
Right.
Back then, software was just a small helper for mechanical systems. It might have controlled a display or a radio. But as planes became more digital, what we call fly-by-wire, the document had to evolve. It went through version A, then B, and finally in 2011, we got the current version, DO 178C.
And here is where I think most people get tripped up.
Uh,
I mean, I always assumed a document like this, a government certification manual, would just be a giant instruction book.
Right, like a recipe. Step 1, do this. Step 2, do that.
Exactly. Step 1, write code in C++ dot. Step 2, run this specific test. But the source makes a huge point that this is just a misconception.
It's the single most important insight of this whole deep dive, really. DO 178C does not tell developers how to build software. It doesn't care if you use C++, Python, or Ada.
It doesn't care about your methodology.
Nope. 2-week sprints, 2-year cycles, doesn't matter. It tells them what objectives must be met. It's focused on the destination, not the vehicle you take to get there.
So it's results-oriented. It's saying, I don't care how you cook the meal, just prove to me it isn't poisoned.
That's a great way to put it. It's evidence-oriented. It asks, can you prove with absolute certainty that this software does what it's supposed to do and nothing else?
And that nothing else part is key.
It's critical. You have to prove there are no unintended side effects.
And the level of proof you need, the stack of paperwork you have to produce, depends on how dangerous the software is, right? The source talks about this DL pyramid.
The design assurance levels. This is crucial for understanding the workload because not all software on a plane is created equal.
Right.
Imagine a pyramid. At the very top, you have level A. This is catastrophic.
The catastrophic means the plane crashes.
It means the plane crashes and people die. This is the flight control computer, the engine control systems.
The big stuff.
The really big stuff. If you are building level A software, you have to satisfy 71 specific objectives. The scrutiny is just incredibly intense.
Because the cost of failure is infinite.
Right. So that's the peak. Below that, you've got level B, which is hazardous.
Hazardous sounds pretty bad, too.
It is. Maybe the system fails and the crew has to work extremely hard to keep the plane flying. There might be some injuries, perhaps fatal to a small number of people, but the plane is still flyable.
Okay, then level C.
Major. A significant reduction in safety margins, discomfort to passengers.
And I'm guessing discomfort is industry speak for it got really bumpy and people were terrified.
Pretty much. Then you have level D, which is minor. The crew can handle it easily. And at the bottom, level E is no effect.
Level E is like the in-flight entertainment system crashing.
Exactly. It's annoying you can't watch your movie, but the plane stays in the air. For level E, there are 0 safety objectives required.
So you can build that however you want.
But for level A, that's where the industry freezes up. The sheer intensity of level A is why aerospace companies have clung to the waterfall method for 40 years.
Let's talk about that. The status quo, the waterfall method, or sometimes the V model. Why is this so entrenched? Is it just because it's old?
Well, it's because it feels safe. Waterfall is linear. It's sequential.
Step by step.
Right. You do all your requirements first months of just writing documents. Then you do all your design. Then you write all the code. And then finally, you test it.
It feels like construction.
It does. You don't put the roof on a house while you're still pouring the concrete foundation.
That makes sense physically. But software isn't a house. Software is abstract, and it changes. You realize halfway through a project that a requirement was wrong.
Exactly. And in Waterfall, if you realize a requirement was wrong 6 months in, it is a disaster. You have to go all the way back to the start. But in aerospace, that rigidity is seen as a feature, not a bug. They think, if we lock everything down at the start, nothing can surprise us.
But the source points out that DO 178C doesn't actually say, thou shalt use waterfall.
Not at all. That is a cultural habit born of fear. The paper explicitly states there are no limitations or restrictions preventing Agile adoption.
So it's just habit.
It's habit. The document demands evidence, and people just assume the only way to generate that evidence is through the traditional method they've used since the 80s.
Okay, so if the document allows for flexibility, how do you actually tell the regulators, the FAA or ESA, hey, we're going to do this differently? You can't just surprise them at the end.
Oh, absolutely not. Surprise, we use Scrum. Probably doesn't fly.
Probably not.
You do it before you write a single line of code. The source details the 5 essential plans. Before a project can even start, you have to submit these plans to the certification authorities. This is your contract with them.
Okay, let's run through these quickly. This seems like the key. First, there's the PSAC.
The plan for software aspects of certification. This is the high-level handshake. It's where you tell the authorities what you're building and what safety level, what DAL you're aiming for.
We're building an autopilot, and it is level A.
Exactly. Then the SDP software development plan.
And this is the important one.
This is the big one for our discussion. The SDP is where you define how you're going to build the software. If you want to use Agile, if you want to use sprints, if you want to use pair programming, you write it down right here.
So you just state your intentions up front.
You do. If you say, we will use 2-week sprints to generate code, and the regulator approves that plan, you are allowed to use those methods.
That's wild. So you just have to write it into the contract. It feels almost too simple.
Well, the simple part ends there, because once you write it, you have to stick to it. Then you have the SVP for verification, how you'll test it, the SCOIP for quality assurance, who watches the watchers, and the SCMP for configuration management, how you track every single change.
So we have our plans. We've told the FAA we're going to be agile, but now we run into the reality of the work. Agile is all about embrace change.
And DO 178C is about control change.
Exactly. The source identifies 3 specific areas where these 2 philosophies just crash into each other: traceability, independence, and change control.
These are the big three hurdles. The paper argues that if you can solve these, you can use Agile in a safety-critical environment, but they are not easy to solve.
Let's start with traceability. This seems like the most bureaucratic one. In the old school world, it means I can point to a line of code and say,
This line exists because of a requirement 42 on page 10.
and vice versa.
Right, a bidirectional link. Every requirement needs code, every line of code needs a requirement, and every requirement needs a test. It's a closed loop.
And if there's code that doesn't trace back to a requirement.
That's dead code. It's not allowed on the plane. It's a ghost in the machine.
In waterfall, this is easy because you write a massive requirements document, like a phone book, before you start.
You number everything.
But in Agile, requirements change every 2 weeks. You're writing them on sticky notes or digital cards. How do you trace a moving target?
The source suggests using product backlog items, or PBIs. In Agile, a PBI is usually just a user story like, as a pilot, I want to lower the landing gear.
Oh.
But to make it DO 178C compliant, you treat that PBI as a kind of container.
A container, like a digital folder.
Yes, exactly. Think of it like a digital folder that travels through the process.
Yeah.
The PBI doesn't just describe the feature. It links the user requirement directly to the specific development task and the acceptance criteria, the test.
Ah, okay.
So when you move that PBI from to do to done, you aren't just saying, I wrote the code. You are inherently creating that bidirectional link. You're building the traceability as you go.
That actually sounds more efficient than trying to do a massive archaeological dig at the end to find where all the requirements went.
Precisely. It requires discipline. You can't be lazy with your JIRA tickets, but it solves the problem. You are building the documentation with the code.
Okay, hurdle number 2, independence. This one's interesting. The rule is you cannot verify your own work.
Right. It's the homework principle. If I write the code for the landing gear, I cannot be the one who signs off saying it works. I'm biased.
You want it to work.
Of course. I might subconsciously skip a test case because I know the code is good. In Level A software, this independence is mandatory.
But Agile teams are usually small, tight-knit, collaborative.
Yeah.
Everyone does everything. Doesn't that break the independence rule?
You'd think so, but it can actually help if you structure it right. The source points to cross-functional teams because your team has developers, testers, and designers all working together daily.
There's always someone else available to verify.
Exactly. And the source also mentions specific practices like pair programming. I've always been fascinated by this.
It comes from extreme programming.
Right. 2 people, 1 computer. One is the driver. They're typing the code. The other is the navigator. They're reviewing the code in real time, watching for errors, thinking about the larger design.
So DO 178C requires verification, but it usually happens afterwards. Pair programming makes it.
Instant. The verification is instant.
So the navigator counts as the independent verifier.
Yes, as long as you document that process. Or you can use test-driven development, TDD, where you write the test before the code. You write a test that fails, then you write just enough code to make it pass.
That sounds like it forces you to think about the requirement before the implementation.
Which is a valid way to satisfy the independence requirement of the standard. It sounds like Agile might actually be better at independence because the checking is constant.
Right, not just at the end of the project when everyone is tired and wrecking to finish.
That is the argument. In Waterfall, the tester might not see the code until 6 months after it was written. In Agile, they see it that afternoon. The feedback loop is so much tighter.
Okay, the third hurdle. Change control. This is the big scary one. In aviation, you need to know exactly what changed, when, and why.
You can't just hack a fix together. And this is where the move fast part of Agile really scares the regulators. They picture cowboys changing code on the fly.
But that's not how it works.
Not in a professional setting. Modern Agile relies heavily on version control systems, things like Git and rigorous backlog management.
So instead of just changing code, every single change is a new version that gets tracked.
Yes. And the source argues that because Agile teams are already obsessed with tracking iterations, Sprint 1, Sprint 2, Release 1.0, they are actually well suited for this. You just need to make sure your software tools are generating the configuration index the standard requires.
The paper trail.
A digital paper trail. If your tools generate that trail automatically every time you commit code, you're safe.
So the tools are there. It's just a matter of using them with a bit more seriousness.
Tailoring is the word the source uses. You can't just use out-of-the-box Agile where you ignore documentation. You have to tailor your Agile process to the rigor of the design assurance level.
So for Level A software, your Agile process is heavy on documentation. For Level D, it can be lighter.
Exactly.
So we've got our plans, we've solved the big three hurdles, now we're actually building the thing. But certification isn't just a final exam at the end, is it?
No, that would be a huge financial risk. You don't want to find out you failed after spending 2 years building. The authorities check in at 4 specific times. They call them the stages of involvement, or SOI.
SOI. Sounds like a space mission. What are the stages?
SOI 1 is the planning phase. They check those 5 plans we talked about. They look at your SDP and say, okay, you want to use Agile? Show us how. If you pass SOI 1, you get permission to start building.
Then development starts.
Right. SOI 2 happens when development is underway, usually when about half the code is written. They come in and look at the code itself.
Are you actually following the plan?
Exactly. Are you doing the pair programming you promised? Are the digital sticky notes linked to the code?
Then SOI 3.
Verification. They check your tests. Have you found bugs? How did you fix them? This usually happens when half the testing is done. They want to see that you aren't just rubber stamping things.
And finally, SOI 4.
The final audit. Everything is closed out. The software accomplishment summary, the SAS is signed. This is the graduation ceremony. If you pass SOI 4, your software is certified to fly.
And this source lists a massive amount of output required here. Source code, executable object code, problem reports. It's a mountain of data.
It is, and technology keeps changing, which creates new types of data. That's why the source mentions that DO-178C is future-proofed. It uses supplements.
Right, I saw that. DO-331, 332, 333. I assume those were just revisions.
They're more like add-ons. You can't rewrite the whole Bible every time a new tech comes out, so they add a supplement. DO-331 covers model-based development. DO-3322 covers object-oriented technology. DO-333 covers formal methods using math to prove code correctness.
So they're basically patches for the rulebook. Here is how you use this new tech legally.
Exactly, which reinforces the main point. The standard is designed to adapt. It is not a straitjacket. It's a framework.
So what's the verdict from the source? Okay, can we actually do this? Can we put Agile on an airplane?
The verdict is a resounding yes. The paper concludes that you do not need to break the rules to use Agile. DO-178C supports safety. It dictates objectives.
And if you can prove you met the objective using an Agile sprint.
The regulator is happy. The barrier is not the regulation.
The barrier is us, or rather the industry's habits.
Correct. It's organizational inertia. It's just easier to do what you did on the last plane than to write a new software development plan for the new one.
So let's wrap this up. We started with this idea that you have to choose between being fast and being safe.
Between innovation and regulation.
And what we've learned is that DO-178C is actually a lot smarter than people give it credit for. It's a support for safety. It says, here's the bar you have to clear. It doesn't say you must crawl on your hands and knees to clear it.
You can sprint over as long as you don't trip.
And for you listening, this matters because the machines we trust with our lives, planes, trains, medical robots, they don't have to be stuck in the 1990s. They can be built with the efficiency of modern tech.
Which theoretically makes them safer, faster, and cheaper to maintain, provided the planning is rigorous. That is the catch.
You can't just wing it.
You have to plan to be agile. You have to be disciplined about your flexibility.
Which leads me to a final thought I want to leave everyone with. If the Bible of aerospace safety actually permits Agile, and if Agile is proven to be faster and often better at catching bugs early, why is the industry still so terrified of it? Is it really about safety? Or is it simply that in a high-stakes environment, nobody wants to be the first one to try something new, even if the rulebook says it's okay?
That is the multi-billion-dollar question.
Thanks for diving in with us. Stay curious, stay safe, and we'll catch you on the next one.